Hi guys, so we're going to do a little lab activity via video. So if you aren't in the classroom physically, then you're going to get this via video and hopefully get the same understanding of the concepts that we're trying to, bring home with this. So in your elements versus compounds lab, so hopefully you have that open in a document form somewhere, okay? We're going to look at elements and describe them and write their symbols. And then we're going to look at compounds that are made of those elements and describe them and write their formulas. And then we're going to do a little bit of follow-up question and answers about properties of those elements compared to the properties of those compounds. So the first element in the table is copper, and the symbol for copper is Cu. Remember that second letter has to be lowercase, okay? All right, so for the description of the element, we're definitely looking for physical state. Is it a solid, liquid, or gas? And we're looking for color, but anything else that you notice by looking at it, like is it shiny or dull? Is it crystalline? Things like that. Powder, crystalline, smooth. You can give textures, things like that, okay? So copper, you have seen copper when you look at a penny, for example, but this is what copper looks like. So it's a solid, and it's shiny. And then, you know what? I'm going to let you interpret the color. You could write copper colored. I mean, it's a pretty unique color. It is an orangish type of metal. Okay. So go ahead and write that description there. Right below that is sulfur. Okay. So sulfur, what I have for you, sulfur's symbol is capital S. Okay. And this is what sulfur looks like. So hopefully you can see in the video that this is yellow, and it's flaky, and it's dull. You can kind of see that there's powder around the inside of the glass vial. Okay. And then oxygen. Now oxygen is a little bit different. Its symbol isn't just O. When it's in its pure form, its symbol is O2. So we put a little subscript 2 after the O, and that's because it's one of our diatomic elements. We're going to be learning about these and referring back to them frequently, but oxygen pairs with itself to form a little diatomic molecule, 2 atoms. That's what diatomic means, 2 atoms. And so oxygen is a diatomic element, and it floats around in little pairs. But this is my vial of oxygen, and if you're like, whoa, wait, that's empty. Well, that's because oxygen is, hopefully you already know, a gas, and it is colorless. So oxygen samples would not be visible to us, okay? Now, when those 3 elements combine and they make an ionic compound, so we're giving and taking electrons and we're forming an ionic compound, they make something called copper 2 sulfate. Copper 2 sulfate. So let me write that formula down so that you have a reference to see, as well as spelling and all of that. CuSO4. Okay, so you don't necessarily have to write the name, but there's the formula, CuSO4. So we've got 1 copper, 1 sulfur, and 4 oxygens, and they form an ionic compound called copper 2 sulfate. And when we get that, here's what we get. Okay, so we have a kind of chalky blue solid. It is crystalline, but if you look at the bottom, there's definitely some powder in there, okay? But definitely big changes from the elements that it started from, okay? Okay, the next element down in the table is sodium. Now, sodium is an interesting element. It's an alkali metal, and I can't remember if we've already learned this or not because I'm advanced making these videos, but alkali metals are highly reactive with water. They're solids, and if you just leave it laying out on the table, it actually reacts with the water in the air. So my sample is going to be a little bit weird looking. First of all, it's stored under oil. So there's oil in this jar that I'm about to show you. That is not the sodium. So don't start describing it as a clear liquid. That's not it. Okay, you want to look for the chunk of metal in the oil when you're describing this. There are also some little white flaky things in the oil because like I said, every time that little chunk gets exposed to air, even the air inside the bottle, it's going to react with whatever water is there. And you're going to end up with these little flakes of sodium oxide, sodium hydroxide, kind of floating around in the oil. So what you really, I'm going to try and get it up here. You really want to look at that cube of metal. Okay. Let's see if I can get it somewhere where you can see it. Okay, well, we got a little bit of, you can see how shiny it is. It's very silvery in color. There's some white stuff stuck to the surface, but that's not, again, that's not the sodium. So the sodium is very, very shiny. There's the top of it. You can see it kind of reflects that red from the label back at you. But it's a very shiny silver metal. And if we were to take it out, which I don't necessarily want you to write this because we're not taking it out, so you can actually see it for yourself, but it's very, very soft. I could cut it with a butter knife. Okay. All right, iodine. Iodine is very similar to oxygen, so make sure that you put I2 as the symbol for iodine, capital I with a little 2 subscript. It pairs up with itself. It's diatomic. Okay. And here is pure iodine. Now, most of you have probably experienced iodine in a liquid form where it's dissolved into either water or an alcohol water mix in your medicine cabinet. And it doesn't look anything like this in there. So this is kind of a glittery, dark blue or black solid. Okay. The color's not really showing up here, so you probably are seeing black, but it does have some definite blue hue to it if you are in person. Okay, now those two get together and they make sodium iodide. I'm going to go ahead and write that out for you so you can see it. Sodium iodide. So there on the bottom, sodium iodide, NaI. Now, notice there's no 2 with the iodine here. So there's not little pairs of iodines inside this compound. It's a single sodium bonded to a single iodine and kind of repeats throughout the crystalline structure. NaI, NaI, NaI. It's not NaI2, NaI2. It's not that. Okay, so 1-to-1 in the compound. Iodine is only required to be diatomic when it is in its pure form. So just I will not exist, but I2 will. But I attached to something else, absolutely, that can exist in a 1-to-1 ratio. Here is what sodium iodide looks like. Okay, it looks like salt because it is. It's a kind of salt. And this kind of salt is actually in our table salt. If you've ever noticed your salt label says iodized, that's because it has some sodium iodide in your table salt mixed with that sodium chloride. Because sodium iodide is a good source of iodine, and we need that in our diets in order to maintain nerve health and cellular respiratory health, okay? All right, last ones here, silicon, Si. Here's silicon. We have these gray, dark gray, shiny, shiny, shiny rocks, okay? So solids, shiny, dark gray, okay? Oxygen, again, O2, don't forget the 2, okay? And, show you an empty vial again because it is a colorless gas. And then when these two get together, they make silicon dioxide. Silicon dioxide. So SiO2, silicon dioxide. Now, in this case, there are 2 oxygens for every silicon. That's not because oxygen is diatomic. It just happens to be how these 2 bond with each other. Okay, if it was calcium oxide, it would just be CaO. But silicon dioxide ends up with 2 oxygens there. So just again, don't automatically put the 2 when it's in a compound. You want to know what the compound is. But when it's in its pure form, oxygen is always O2. Okay? Well, silicon dioxide is what our glass is made of. So I just have a vial of broken glass. Okay, so colorless, solid, maybe shiny, I don't know. However you want to describe that, okay? Okay, flip it over or scroll down if you're on a computer to the questions here. So number 1, what type of ion do metals form? What type of ion do metals form? Okay, is it positive or negative? Well, It's positive, cation. Metals give away electrons. They don't have very many valence electrons. They're on the left side of the periodic table. So they're going to give away the electrons that they have to get to that full layer underneath and become stable. Okay, so cations. What subatomic particles remain the same when a metal atom ionizes? Okay, well, if I've got copper and it's becoming copper with a 2+ charge, the particles that remain the same are the protons and the neutrons. Those are not transferred. They're in the nucleus. They are not going anywhere, okay? The things that are transferred are the electrons. So number 3, what subatomic particle is transferred from the metal atom when it becomes an ion? And that is electrons, okay? All right, 4, what type of ion do nonmetals form? Well, they form an anion, a negative ion, okay? They are very close to having H. They're very close to being stable. They just need to gain a couple of extra electrons to become stable. 5, what subatomic particles remain the same when a nonmetal atom ionizes? Again, your nucleus isn't changing when we form ions. We're not changing the nucleus at all, okay? That's nuclear chem. That's chapter 25. Hold your horses, okay? So they're going to gain electrons. Protons and neutrons stay the same, okay? So I answered both 5 and 6 there. Number 5, protons and neutrons. They stay the same. Number 6, what's transferred? Electrons. It is gaining electrons from another source, from a metal, okay? All right, 7, the first 2 compounds on the front chart are ionic, but the last compound is not. Using the compound formula, how can you tell that the last compound is not ionic? Well, formula is this, right here, SiO2. So why is this one not ionic when the other 2 are? Well, we were just talking about metals giving away electrons and nonmetals gaining electrons. You have to have both of those in order to have an ionic compound. A metal giving away and nonmetal taking their opposite charges stick together, and that's an ionic compound. Well, is either one of these a metal? Nope. Silicon is in our metalloids category. Oxygen is in our nonmetals. So this compound is not made by giving and taking electrons, so it cannot be ionic. Okay, it doesn't have a metal. 8, are the characteristics you wrote on the chart the same for the compounds and the elements that form those compounds? Okay, I need to just make sure that you understand this is the major point of this, okay? Sodium, just to go back to this one, shiny silver solid metal. If I stick this in water, including saliva in my mouth, it would explode, okay? Here, iodine, this is actually a super toxic solid. We don't want to eat this. That's why we use it to clean our cuts, because it kills stuff, okay? It's a black solid, blackish blue, shiny, crystally solid, okay? And then we get this. When you put those 2 together, you get something that is actually part of your table salt because we need it in our diets in order to be healthy. So we have, yes, all 3 are solids, but no, their properties do not come with them when they become ions and part of an ionic compound, okay? There's only 3 choices for physical state: solid, liquid, gas, okay? And here I have a solid and a gas for silicon and oxygen becoming a solid. So one of them kept its physical state, one of them didn't, but no, we're not carrying properties, okay? So the answer to question number 8 is no, their characteristics are not the same. Not only do their physical states sometimes change, there's only so many of them, okay? But their colors are changing, their lusters are changing, okay? If we were able to open these and test their chemical properties, those would absolutely be changing, and that's what we're going to get at with number 9. What are 2 or more properties, other properties that might be different between these compounds and elements, okay? And I've already listed several of them. Reactivity. Remember, the sodium explodes in your mouth, but the sodium iodide does not, okay? We need that. Solubility. Sodium iodide, well, all of those ionic compounds dissolve in water, but their elements do not, okay? You're looking at other things too. Smell is going to be different. Taste is going to be different. I already said reactivity, okay? But write a couple of things down that will be different. Okay, so that's this activity. I hope that it made sense. Let us know if you have any questions. Thanks.